You know, it's interesting because currently this worksheet is labeled in my computer assignment 80, but on the assignment calendar it says it's we're something along the lines that we're working on it in 79. So I'm going to call this 7980 review worksheet. Okay, let's take a look. There's 21 questions. That should keep us busy for a while. Write the first 5 terms in the sequence. A sub n equals 2n plus 1 factorial over n plus 1 factorial. You know, and as is always the case, I recommend that you actually try and do this assignment on your own and then come here now to check your work, your thinking, and your answers. Okay, so we're supposed to find the first 5 terms, so I want a sub 1, which means I replace n's with 1. There's an n. 1 times 2 is 2, 2 plus 1 is 3, 3 factorial. And then 1 plus 1 is 2, I have 2 factorial on the bottom. So 3 times 2 factorial, and I get a sub 1 is 3. Okay, what about a sub 2? Well, a sub 2 is going to be 2 times 2 is 4 plus 1 is 5 factorial over 2 plus 1 is 3, 3 factorial. That's going to be 5 times 4 times 3 factorial. And so I get 20. I plug in a 2. What happens when I plug in a 3? A sub 3. 6 plus 1 is 7 factorial. 3 plus 1 is 4 factorial. 7 times 6 times 5 times 4 factorial. So that's 30 times 7 is 210. And we're plugging in for the first 5 terms. Okay. We said 4. 4 times 2 is 8. 8 plus 1 is 9 factorial. 4 plus 1 is 5 factorial. So 9 times 8 times 7 times 6 times 5 factorial. 42 times 72. Yeah, no, sorry, not without a calculator. 72 times 42, and I get 3024. 3024. And if we want a sub 5, well, I'm going to put a 5 in there and get 11 factorial. 5 plus 1 is 6 factorial. So 11 times 10 times 9 times 8 times 7 times 6 factorial over 6 factorial. Wow. So 90 times 11 is 990 times 56. 990 times 56, and I get 55440. And so those are our first 5 terms. Okay, 2. Simplify the ratio of factorials. Oh, okay. We've got n plus 4 factorial over n plus 2 factorial. This one's bigger than this one, so I'm going to write these factors down, reducing this number by 1 each time until I get here. So I'm going to have n plus 4 times 1 less than that, n plus 3 times 1 less than that. Ooh, look, n plus 2. And I'm going to stop there because that's what I have on the bottom. Those can cancel, and I'll be left with n squared plus 7n plus 12. That's my simplified version. Okay, 3. Which of the following choices represents this using sigma notation? Well, it looks like all my choices here after the sigma are linear, so I'm imagining that that these values, 3, 4, 5, well, yeah. It's interesting because I noticed that some of the sigmas start with 1 and some of the sigmas start with 0. Huh. Well, let's try both and see what both would look like. Okay. 0, 1, 2, 3. so we're starting with negative 3.9, negative 7, negative 10.1, negative 13.2. Okay, so I suspect that the slope will be the same for both of these, but let's just see. So to find my slope, I'm going to do 2 minus y1 over x2 minus x1. So it's minus 7 plus 3.9 is going to be minus 3.1 over 1, or minus 3.1. So there's our slope. Okay. And I notice that that knocks out A and D because the slope is 3.9 on those. So now I just need to figure out, am I starting with 0 or am I starting with 1? Well, let's see. I've got that. Oh, and I've got a y-intercept. So I guess the model here would be minus 3.1 n. No, they're using I. Minus 3.9. Now, does that make sense? Well, let's take a look. So if I plug a 0 in there, well, I do 3.9. Okay. So A sub I. All right, what about this one? Well, this one has the same slope, minus 3.1, but I don't know the y-intercept like I did over here. So I'd have to find the y-intercept. Oh, okay, let's find the y-intercept. Y equals mx plus b. So ours is negative 3.1 I plus b. So I'll plug in this ordered pair, 2, negative 7. And so that's going to be negative 6.2 plus b equals negative 7. So if I add 6.2 to both sides, I get that b equals negative 0.8. And so this is going to be minus 3.1 I minus 0.8. Okay, so that would have to be the case. No, it's not there at all. Oh, but this one is there. Oh, that's perfect. So this is choice D. And yeah, it was much easier to do, though I was uncomfortable because we don't normally start with 0. In fact, our sigma shortcuts for those polynomials, yeah, they need this to be a 1, not a 0. So I'd have to convert first. Okay, well, that's good to know and see and recognize. Let's see. Where are we now? We're 4. Find the sum of the infinite series in each case. And this is number 4, and I got part A. Sigma goes from I equals 1 to infinity of 7 1/10 to the I. Okay, so so we I remember when we did this in the video, we pulled that 7 out and looked at 1/10 to the I. And you know, the thing about 1/10 to the I is, well, or now, this thing about 1/10 to the I is, couldn't I use my infinite sum formula? I have an infinite sum. This is geometric, you know, that exponential situation. And the infinite sum of infinity is 1 minus r. Okay, and so that A is that starting amount, which I believe for us is 1. And our r is 1/10, so I got 1 over 1 minus 1/10. It's going to be 1 over 9/10, which is 10/9. The sum of, really, 10/9? Where do I feel like it's off a bit? Yeah, I feel like that's off a bit because if I add up 1/10 plus 1/100th plus 1/1000th and so on, I'm going to have 0.1 plus 0.01 plus 0.001 and so on, which is going to be 0.11111, or 0.1 repeating. Okay, so let's see what we can say about 0.1 repeating. 0.1 repeating, I don't know what it is, so I'm going to say that's x. I'm going to multiply both sides by 10. And then I'm going to subtract. These will cancel. And have 10 equals 9x. Oh yeah, x equals 10/9. Yep, sure was 10/9. Just felt weird. Oh, because it was a sum. That's why. I understand now. So the sum is 10/9, but don't forget we've got this 7 times 10/9, or 70/9. Here's my answer. But let's go back again and say, hey, don't we have this infinite sum formula, which has that initial amount over 1 minus r. Okay, so my initial amount here is 1, right, because I'm plugging in a 0, over 1 minus 1/10. So this is going to be 10/10 minus 1/10 is 9/10. And I'm going to flip and multiply, and that's going to give me 10/9, just the same as I did it in our middle school way. Don't forget, though, to multiply by that 0.7. Okay, what's next? Oh, we need to do b. b is also an infinite sum. K equals 1 to infinity. 8 times 2/7 to the k. Okay, so my initial amount, 2/7 to the k equals 1 to infinity. So 1 over 1 minus 2/7 is 1 over 5/7, which is 7/5. Don't forget times the 8 equals 56/5. Yeah. We're going with that. Okay, 5. 5 says find a sub n for this arithmetic sequence. A sub 1 is 7, and a sub 12 is 24. So D, well, D is that common difference that we can find. We know it's a synonym for m. 24 minus 7 over 12 minus 1, right? Because these are n values, and these are a sub n values. So I get 17 over 11 for my d value. And I only see one choice with 17 over 11, so I'm kind of not interested in going any further. But let's just confirm. So we know that formula is a sub n equals a sub 1 plus n minus 1 times d. I believe that's our arithmetic formula. A sub n and minus 1 times d. Good. Okay. Well, we have this d value, and a sub 1 was given to us. So I'm going to have 17 over 11 and minus 1 plus a sub 1 is 7. That's pretty much exactly D. So, yeah, I'm going with D for number 5. 6. Determine if the following sequence is arithmetic or not. If it is, find a common difference. If not, explain why not. Got 1/3, 1/2, 2/3, 5/6, 1. Well, I find it really hard trying to figure out whether this is an arithmetic sequence or not without seeing a common denominator. because it's just going to be a lot of work to try and find the difference here between these two fractions without adding that, not without a common denominator. So common denominator would be 6. So I'm going to multiply this by 2 over 2, here by 3 over 3, here by 2 over 2, here by 1 over 1, and here by 6 over 6. And so it looks like I have 2, 6, 3, 6, 4, 6, 5, 6, and 6, 6. Yeah, going up by d equals 1/6. So yes, this is arithmetic. Because there's a d. I mean, there exists a d, but because there is a common difference, d. And you might want to say in this case d equals 1/6. Okay, so let's take a look at the next one. 7. Find the sum in each case. N equals 1 to 41, 5, n minus 1. Okay, well, it's sort of set up for me to use sigma shortcuts, though this is arithmetic, so you could use the sum of an arithmetic sequence formula. Maybe we should do both. N equals 1 to 41 of n minus n equals 1 to 41 of 1. Well, this is the sum of a constant, which we know is n times c. And here, the sum of n, remember, is n plus 1 over 2. And don't lose that coefficient. So, oh look, I could pull a 41 out of both of those. I could divide that by 2. So I'm going to have 105 minus 1, which looks like 41 times 104. 41 times 104, and I get 4264. Okay, so let's think about our arithmetic sum formula. Remember, we have that arithmetic sum formula. S sub n is n over 2, a sub 1 plus a sub n. Okay, so looks like our n is 41. So s 41 over 2. A sub 1. Well, if I plug a 1 in there, 5 minus 1 is 4. And if I plug a 41 in there, so 5 times 41 is going to be 205, minus 1 is 204. So it's going to be 41 over 2 times 208. I guess that can reduce to 104. Hey, look, 41 times 104 again. Yep, so we can use our arithmetic sum, or we could use our sigma shortcuts. All right. And I think there was a part B there, wasn't there? Yeah, part B. Let's take a look at that. B says we're looking for the sum. N equals 1 to 33 of negative n minus 4. Again, we could use our sigma shortcuts, or we could use sum of an arithmetic sequence. So let's look at both. We've got negative 1 n equals 1 to 33 minus n equals 1 to 33 of 1. Okay, so my sum here will be 33 times 34 over 2 times that negative 1 minus this times this. It'll cancel. Okay, so I have negative 17 times 33 minus 33, and that gives me negative 594. Okay, and let's use our arithmetic sum formula. N over 2, a sub 1 plus a sub n. In our case, we're looking for the sum of 33, so we're going to have 33 over 2, a sub 1 So let's say a sub 33. Okay, how do I figure out a sub 1? Well, I'm going to plug a 1 in. Minus 1 minus 4 is minus 5. And what about a sub 33? Well, I plug a 33 in now. So minus 33 minus 4 is minus 37. Okay, so that's going to be minus 42 times 33 over 2. And it'll become minus 21 times 33. Minus 21 times 33. Oh, and I don't get the same thing. Did I make a mistake over here? N plus 1 over 2. No, that looks good. Pull out that minus 1. So let's do the multiplying. 33 times 34 divided by 2 minus 33. Oh, that was supposed to be minus. Minus 561 minus 33. I get 594. So let's come back over here. That n is 33, and a sub 1 is minus 5, and a sub 33, it's going to be minus 33, minus 4 is minus 37. Okay, that's very interesting. Minus 37 minus 5 times 33 divided by 2. I get a different number. How come that's not working? I'm not doing it the long way. But I do find it a little awkward. N times 1, negative 1. I wish you were here to tell me what I'm missing. A sub 33. Negative 33 minus 4 is negative 37. A sub 1 is negative 5. And what did I get? Oh, I got negative 693. Grr. Isn't that interesting? It's just really unexpected. I will admit, surprise. Surprise! Yeah. I just, I wish you had a thought to share with me about that. Well, you know, I could move on, but I'm actually checking it with a spreadsheet. Here equals, here equals negative 1 times, hold on a second while I check this out, times this minus 4. Okay. And there. Fill. And filter. There's fill. Fill down. Yeah, negative 37. How about a sum? Sum of all these values. sum of, it's an equal sign. Just another minute, I'll be done with this. And then we can figure out which one is correct and which one is not correct. It's very interesting. 693 is correct. Whoa. That's not at all what I was... Oh, I see the mistake now. That's supposed to be a 4. Which is, instead of 33, now I'm going to have 132. Yep, negative 693. I really do like that idea of persevering to understand and of using that persevering to sort of help you actually find your mistakes. Oh, that was fun. Thanks for your patience with that with me. I know you didn't want me to go looking for that answer, but I wanted to, and it was fun. Okay, find the indicated partial sum. 23, 35, 47, 59, and we want the sum of the first 16. I guess this continues. This is a sub 1. Is this linear? Well, this goes up by 12, this goes up by 12, this goes up by 12, so yeah, my D is 12. And in order to find the sum of the first 16, if I'm going to use this sum formula, I need a sub 1, but I also need a sub 16. So in order to find a sub 16, I have to write the rule. A sub n is going to be a sub 1 plus n minus 1 times d. Okay, so our d is 12, and our a sub 1 is 23. And we want to know what we get when we plug in a 16. So 16 minus 1 is 15. 15 times 12 is 180, I believe. 15 times 12, 180, plus 23. And so I get 203 for a sub 16. That's a 203. That's going to be 8 times 2, 26. 8 times 2, 26. And I get 1808 as my sum. Okay. 9. A large asteroid crashed into the moon of another planet, causing several boulders from the moon to be propelled into space towards the planet. Astronomers were able to measure the speed of one of the projectiles. The distance in feet that the projectile traveled each second was given by this arithmetic progression. The distance the projectile traveled, find the 7th second. Okay. So, and is it saying find the total distance or just find the distance in the 7th second? Yeah, so it's just the 7th. So I'm looking for a sub 7, and they've given me a sub 1, 18, and, well, ooh, I don't even know. Is this arithmetic? Yes, I'm told an arithmetic progression. Okay, so let's see what we can do with this. We know that a sub n equals a sub 1 plus n minus 1 times d. Gonna have to find that. I know my a sub 1. That's cool. And I'm looking for a sub 7. Let me put a 7 here. Okay. Oh, but I guess I should only do that after I find the d. So hold on a second. Let's just leave it as n for now. And let's find that d. Okay, so we know that d is that common difference. Our first value was 18. Our second one was 54 over 2 minus 1. Is that 36 over 1? Let's see, if I add 18, that's 4. Yep, 36. So I get d equals 36. But you know, just to be sure, I might want to check by using 90 minus 54 over 3 minus 2. So 90, oh yeah, that is 36. Okay, so there's my d value. I'm going to plug my d in. I have a sub 7 equals 18 plus 7 minus 1 times what was our d value? 36. So 6 times 36 is 216 plus 18 we get 234 feet in the 7th second. Yeah, this is speeding up. Okay, at the grocery store, cans of soda are stacked in a triangular formation for display. Each row has one fewer can than the row below. 16 rows, and the top row contains one can. How many cans are needed for the display? Okay, so I got one can. And then underneath it are two cans. Yeah, one fewer. Wait. Each row has one fewer than the one below it. So this is going to have 3 cans on it, and so on. Okay. So I can see here that I'm going up by 1 can each time. So I know my D is 1, and my A sub 1. A sub 1 is also 1. And I want the sum of 16. A sub 16, right? So on the 16th row, there are going to be 16 cans. And I want to know S sub 16. So I got 16 over 2. And I got A sub 1 plus A sub 16. So that's going to be 8 times 1 plus 16. Or 8 times 17. It's a bunch of cans, isn't it? So 126. 17 times 8 is 136. It's a bunch of cans. Okay, 11 on the back now. 11 says, write the nth term for the following: 9/4, 27/8, 81 over 16, 243 over 32. All right, so one of the things that I mentioned in the earlier videos here was that sometimes you need to be able to recognize some things, some patterns, and that's what I see here. The other thing I mentioned, I do see patterns here. The other thing that I mentioned was the importance of maybe putting in some n values. And I noticed something here in the numerator that's different than here in the denominator. Here, I see 3 squared, and 3 to the 3rd, and 3 to the 4th, and 3 to the 5th. So I've got 3 squared, 3 to the 3rd, 3 to the 4th, 3 to the 5th. But then in the denominator, I see a different pattern. That's 2 squared, 2 to the 3rd, 2 to the 4th, 2 to the 5th. So can we build a rule here for the nth term that somehow relates this n value to what we're seeing here? And to me, it looks like this number is the same, but that this number is one more than that. Is that true? This number is one more than that, and these are the same. So I could write this as 3 to the n plus 1 over 2 to the n plus 1, or I could combine them into 3 halves to the n plus 1. That would work as well. Okie doke. All right. Next. Identify the value of the nth term as a geometric sequence. Okay, we've got a geometric sequence. Remember, geometric sequence uses common ratio, not common difference. And we want n minus 1. Okay, and what do they give us here? Given that a sub 1 is 1/4, given that r is 1/3, so there's our a sub n. And now they will tell us, hey, can we find a sub 5? So it's going to be 1/4 times 1/3 to the 5 minus 1. 5 minus 1 is 4, so this is 1/4 times 1/3 to the 4th. 1/3 to the 4th is going to be 1 over 81. And so I end up with a sub 5 being 1 over 324. I think so. 81 times 4. Yeah, 324. There we go. Okay, what's next? Oh, another one of those sums that includes, oh, none of them have 0. Oh, but some of them are infinity. Oh, find each. This isn't multiple choice. Ah, this isn't multiple choice. This is 4 separate problems. Okay, now I understand. So let's remember we have some sum formulas. We've got the sum of infinite that we talked about. And this only works, remember, when your r is between 1 and negative 1. Yeah, I would feel more comfortable saying that. Okay, now what? Okay, our first one. Oh, I need the regular geometric sum formula. It's a sub 1 over 1 minus r to the n over 1 minus r. Huh? I believe so. Okay, so that pen has had its day. Let's try the next one. Okay, and I'm looking at sigma equals 1 to 8 of 3/5 to the n. Okay, so my r is 3/5. My a sub 1, if I plug a 1 in there, I also get 3/5. So 3/5, 1 minus, oh, that's a sub n, that's 8. So 3/5 to the 8th over 1 minus 3/5. Okay, so 3/5 raised to the 8th, 1 minus that number, times 3/5 divided by 5/5 minus 3/5 is 2/5, and 2/5 is 0.4. I get 1.474 as my sum. Okay, B. B says n equals 1 to 7, 2 times 1/5 to the n minus 1. Okay, again, it's a finite sum. Here, we're told to use excuse me, I'll be right with you. Okay, so we have another geometric sum. We want the sum of the first 7. A sub 1. If I plug in a 1 here, 1 minus 1 is 0. 1/5 to the 0 is 1 times 2 is 2. So I'm going to have 2, 1 minus 1/5 to the 7th over 1 minus 1/5. Okay. So we've got 1/5 0.2 raised to the 7 minus 1 is 6 times, whoa, 6. Oh, no, I went in here. Sorry, 7. Okay. 0.2 to the 7th, 1 minus that number, times 2 divided by 4/5. I get 2.499968, or 2.50. Okay. Okay. Third one. Third one is an infinite sum. So sum of infinite is a sub 1 over 1 minus r. And this goes from 1 to infinity, -3 times third to the n minus 1. Okay, so if I want to know a sub 1, I'm putting in a 1 here. 1 minus 1 is 0. 1/3 to the 0 power is 1. 1 times negative 3 is negative 3. And then 1 minus 1/3. Okay, so 3/3 minus 1/3 is 2/3. And if I do my flip and multiply, I get negative 9/2. And then that last one, 14d, we've got another infinite sum. Negative 4 3/5 to the n minus 1. Okay, so I'm going to use the sum of infinite, which is a sub 1 over 1 minus r. Okay, so if I plug a 1 in here, again, 1 minus 1 is 0, 3/5 to the 0 is 1, 1 times negative 4, I'm going to have negative 4 on top. And then 1 minus 3/5 on the bottom. Well, that's going to be negative 4 over 2/5, which is negative 20 over 2, or negative 10. So my sum here is negative 10. Okay, number 15. 15, a person made 30,000 during their first year. So a sub 1 is 30,000. Each year she received a 10% raise. Oh, so 1.10, right? Because I'm doing 1 plus 0.10, 10%. 10% each year. So 1.1 to the n minus 1 times 30,000. I believe that's what I want, right? Because if I plug in a 1 here, this is going to be 0, it's going to be 1. That's what she made in her first year. Okay, so I think this is my geometric formula. Find the total earnings for the first 9 years. Okay, so this is my geometric model. However, I need to use a geometric sum model, and I want to find the sum of the first 9 years. Okay, so remember that sum formula has a sub 1, 1 minus r to the n over 1 minus r. Well, there's our r. So I put 1.1 there, put 1.1 there, and n is 9, and a sub 1 is 30,000. So let's see what we get. Don't be rounding this. 1.1 raised to the 9th. Okay, and I want 1 minus that number. I want to multiply that by 30,000. And then I want to divide that by 1 minus 1.1. And I get 407,384.31. 407,384.31. There's choice B. Wow, she made $400,000 in under 10 years. Good for her. Okay, 16. Initially, there were 4,000 bacteria in a culture. Scientist is testing new antibiotic, which causes the number of bacteria to be cut in half each hour. That's cool. Number of bacteria, T hours, is n of T equals 4,000, 1/2 to the T. How many bacteria after 7 hours? So the number of bacteria after T hours, yeah, this is just plug in a 7. 1/2 to the 7. Okay, 5 raised to the 7. And then multiplying that times the 4,000 we started with, and we get 31.25 after 7 hours. Cool. Yeah, that wasn't a geometric sum. It was just what is the value of the 7th term. Okay, that was 16. 17 looks like it's more sigma shortcut problems. So we've got n equals 1 to 20 of n minus n squared. Sure. That's n equals 1 to 20 of n minus n equals 1 to 20 of n squared. So our shortcut, n plus 1 over 2 for this, and our squared shortcut, n plus 1. No, it is not n plus 2, it is 2n plus 1. And no, it is not over 3, it's over 6. So let's plug in our 20 for n. So we've got 20 times 21 over 2 minus 20 times 21 times 41 over 6. So that's going to make 10, or 210. We're going to do 10 times 21 minus. I can take a 3 from here and a 2 from here. So I've got 420. And so I get negative 210. There's my answer to that one, negative 210. Okay, I think so. 70. Yeah, I think I left that off. Yeah, something went wrong there. Hold on, let me actually calculate that. Okay, I'm good with the 70 times 41. 28, 70. And this is still 210. Okay, so 210 minus that 2870, and I get not that number, but negative 2660. Sorry about that. All right, part B says, how about figuring out the sum n equals 1 to 12 of negative 2/3 minus 5n minus 2n squared. Sure. So sum of 2/3 from n equals 1 to 12 minus 5 times the sum of n from n equals 1 to 12 minus 2 times the sum from n equals 1 to 12 of n squared. Well, remember our shortcut for a constant is simply multiplying n times c. So that's going to be 8 minus 5 times 12 times 13 over 2 minus 2 times 12 times 13 times 25, right? Because this is 2n plus 1. 2 times this is 24 plus 1, 25 over 6. Do a little simplifying. And so I'm going to have negative 8 minus 30 times 13. Well, 30 times 10 is 300. 30 times 3 is 90. I get minus 390. And then here, 4 times 13 is 52 times 25. All right, so let's see what we get there. We've got minus 8 minus 390 minus 52 times 25. And I think that's minus 1698. Just to be sure, I'm actually going to go back to the unsimplified step and see if I get the same value. 5 times 12 times 13 divided by 2 minus 2 times 12 times 13 times 25 divided by 6. Yep, same, negative 1698. Oh, look, there's one last one. And this one doesn't start with 1. Good. Then this goes to 20 through n minus, well, that's kind of stupid. I think that's supposed to be 3n squared, because otherwise, why wouldn't you just write the sum of n? Yeah, well, I'll do the problem as written, but really, I think that needs to be there. So maybe I'll get that fixed by the time you watch this video. It'll be interesting to see. So remember here, our sigma shortcuts only work if we start with 1. So we're going to do 1 to 20 of n minus n equals 1 to what number? No, not 10. Not that number. We want to count from the 10th one on as part of this answer. So that has to be one less than that number. Okay, so that's going to be 20 times 21 over 2 minus 9 times 10 over 2. So that gives me 210 minus 45. 155? 165. Get 165 there. Yeah, now let's try it with a squared here. That would be better. At least more likely to be a test question. So I'm going to have the sum of n from 1 to 20 minus 2 n equals 1 to 20 of n squared. And I want to subtract from that 3 sum of 1 to 1 less than this, 9 of n minus 2 from 1 to 9 of n squared. Okay, so that's going to be 3 times 20 times 21 over 2 minus 2 times 20 times 21 times 2 times this is 40 plus 1 is 41 over 6. And this one, this will be 3 times 9 times 10 over 2 minus 2 times 9 times 10 times 19 over 6. All right, so here I can do some simplifying. With 30 times 21. That gives me 630 minus, I can do some canceling here, 7, 10, 70 times 41 times 2. I get 5740. And we're supposed to subtract from that 45 times 3, which I think is 135, minus, took a 2 out of there and a 3 out of there, so 6 times 5 is 30 times 19, and I get 570. Okay, so 630 minus 5740 minus 135, minus a minus is plus 570. And I think I get negative 4675. Okay, that was 17C. Okay, 18, write the first 5 terms in the sequence. A sub O equals 4, A sub 1 equals negative 3, and A sub n equals negative 3, A sub n minus 1, minus 2, A sub n minus 2. Okay, so this is a recursive situation where this one depends on the value of the last one and the value of the one before that. So, for example, we've got the first 2 terms. We're looking for 5 terms. If I'm looking for A sub 2, well, that means n is 2. That means n is 2. So I could write this as A sub 2 minus 1 is 1. A sub 2 minus 2 is 0. Oh, I see. So to find this term, I need negative 3 times the last one minus 2 times the one before that. Okay, so that's going to be negative 3 times negative 3 minus 2 times positive 4. So there's 9 minus 8 is 1. A sub 2 is 1. A sub 3, well, 3 minus 1 is 2 minus 2. 3 minus 2 is 1. So I'm going to put A sub 1 in here, right? Because this one is negative 3 times the last one minus 2 times the one before that. And so for us, we have negative 3 times 1 minus 2 times negative 3. So that's going to be minus 3 plus 6 is positive 3. Just checking. Yep. Positive 6 minus 3, positive 3. Okay, we still need to find a sub 4, right? Because we're looking for the fifth. And we've got a sub 0 and a sub 1 equals 4 equals negative 3. So 1, 2, 3, 4. Yeah, I need one more. I need a sub 5. So, I'm sorry, I need a sub 4. That's negative 3. A sub 4 minus 1 is 3. Minus 2. A sub 4 minus 2 is 2. So, what was a sub 3? A sub 3 was 3 minus 2 a sub 2. Oh, drat. I forgot. A sub 2. A sub 2. I have to refind. A sub 2. A sub 1. A sub 0. So, what's that going to be? A sub 1. Negative 3. We got 9. Sub 0 is 4. That's 8. So, we got 1. So it's negative 9 minus 2 is negative 11. So 4, negative 3, 1, 3, negative 11. I think that's what I just found. First 5 terms. This is some freaky terms. Recursive. Hate it. Okay. Oh, clearly the earlier version of me didn't like it either because there's only one recursive problem on this review worksheet. Okay. Oh, no, there's a second one for 21. We've got some binomial expansions, though, to look at. We've got a minus 3b to the 4th. Okay, so that's 1, 4, 6, 4, 1, using Pascal's triangle. So I've got 1 times a to the 4th minus 3b to the 0 plus 4 times a to the 3rd minus 3b to the 1st plus 6 times a to the 2nd minus 3b to the 2nd plus 4 times a to the 1st minus 3b to the 3rd, and then plus 1 times a to the 0 minus 3b to the 4th. Okay, well, let's tidy this up. To the 0 is going to be 1. 1 times a to the 4th is a to the 4th. We've got negative 3 times 4, so that's minus 12, a to the 3rd b. Negative 3 times negative 3 is positive 9. 9 times 6 is 54. A squared b squared. Negative 3 to the 3rd is negative 27. Negative 27 times 4 is negative 108. A b to the 3rd. And finally, we're going to have plus 81 b to the 4th. And there's my expansion. So much faster than FOIL. Okay. Oh, wow. I'm sorry, I just looked at the last problem. It's not multiple choice. It's 3-part recursive. Okay, so part A, we've got a sub n equals 3 for n equals 1 and has a n sub 1 plus 2 for n equals 2, 3, and 4. Okay, so a sub 1 is 3. A sub 2 is going to be a sub 2 minus 1 plus 2, which is a sub 1 plus 2, right? I mean, think about it. This one, this notation here that I see says, this one relies on the value of the 1 before this, plus 2. And the value, you know, so here's, I'm looking for a sub 2, and the value before a sub 2 is a sub 1. So a sub 1 is 3, 3 plus 2 is 5. A sub 3, well, that's going to be a sub 3 minus 1 plus 2. That's going to be a sub 2 plus 2. A sub 2 was 5 plus 2, 7. A sub 4, well, it's going to be A sub 4 minus 1 plus 2, which is A sub 3 plus 2. A sub 3 was 7, and I get 9. And do we want 4 or 5? 4. So 1, 2, 3, 4. Done. Okay, part B. B says A sub n equals 5 for n equals 1, 2 a sub n minus 1, plus 3 for n equals 2, 3, and 4. Okay, well, we know a sub 1 is 5 because of this. A sub 2, however, if I plug a 2 in there, 2 minus 1 is 1. So it's going to be 2 a sub 1 plus 3. Well, we know what a sub 1 is. I'll get 13. A sub 3, well, 2 times the last term. 2 times a sub 2 plus 3. 2 times the last term plus 3 is going to be 29. And a sub 4, well, that's 2 times the value of the last term, which is 29, plus 3, 58, 61. And so here are my first 4. Okay, and then the last one on our review worksheet is part C. A sub n equals 4 for n equals 1 and 2, and negative 3 a sub n minus 1 plus 5 a sub n minus 2 for n equals 3 and 4. Well, you know, this is a pretty straightforward sequence with 1, 1, and that's, you know, n equals 1, 2, 3, 4. So when n equals 1, I get 1. Oh, I get 4. And for n equals 2, I also get 4. Now, when I get to n equals 3, I'm looking for a sub 3. Well, using this notation, if I plug a 3 in here, a sub 3 minus 1 is 2, plus 5. A sub 3 minus 2 is a sub 1. So a sub 3 is 3 times 4 plus 5 times 4, which is going to be 8 times 4, or 32. Okay? And you can also understand this as if you want the value of the third term, you have to take 3 times the value of the last term plus 5 times the value of the term before that. Okay, and then finally a sub 4. That's going to be 3 times a sub 3 plus 5 times a sub 2. Okay, so a sub 3 is 32, and a sub 2 is 4. So that's 96 plus 20, or 116 for a sub 4. All right, well, there you go. That's reviewing for our sequences and series assessment. Hey, I hope this was helpful, and don't forget to rest before your assessments. Rest is very, very important and often underappreciated by amazing high school students. Okay, take care, everyone.